so that I don't have to shout anymore. So Sarah Wells is someone that came to our mind as someone we absolutely had to introduce to the testing community for kind of two reasons. One is observability is a thing that everyone remotely even interested in testing should understand and know. Second reason being that the work that she does at Financial Times is awesome. And the third reason, kind of connected with the second one, is that it's really a delight to have a European person sharing on this topic that otherwise seems so America-centered. So welcome, Sarah, and the stage is yours.
Thank you. I'm really disappointed because this is a Financial Times pink, but the projectors just kind of made it a bit of a... Like, so just imagine it's a really sort of salmon pink, because I wouldn't want to be off-brand. Okay, so I am a technical director at the Financial Times in charge of operations and reliability. Before that, I was an engineer and I was in charge of our content publishing platform. I want to talk to you about building cloud-native systems and how it changes how we approach quality, what it means for how we build, test and operate our systems. And I'm going to go into detail about what I mean by cloud native a little bit later. But effectively it's about building systems where you build them to run on the cloud rather than just shifting them to run on the cloud. And we've been doing cloud native type things at the Financial Times for 4 or 5 years now. So we have quite a lot of experience. And it started with moving our content, or rewriting our content publishing and delivery platform. And we then did the same thing with our website and also with our subscription services. And I have been involved in this all the way through. So as Marit said, this is my first testing conference, and I realised basically too late that I needed to up my gift game and that I have none in this, so I just stuck one in. This is what it's like to operate a cloud-native system. You get an alert, and then suddenly you've got no idea what's going on, but everything is going on. Sorry, that is the only gift that I'm going to do in the whole thing. Apologies for that. But I do have a picture, which is a picture I took, which is of the FT being printed at our print site in Bow in East London. It's great. We get to go and do a print tour. It's fantastically exciting if you ever get a chance to do it. But the Financial Times don't describe ourselves as a newspaper. We describe ourselves as one of the world's leading business and financial news organisations. And the reason that's how we describe ourselves is because most people don't read the Financial Times on print. They read the website. They read it on their phone, tablet, laptop. We have a paywall, and we make more money from people subscribing than we do from advertising. And if you know anything about the news industry, print advertising is not doing well, digital advertising is not doing well, so making money from a paywall is a really good way to actually make money in the news industry. And the news industry is struggling. Lots of local newspapers are having problems. Any kind of newspaper that doesn't have a paywall is trying to work out where do we get money from. So it's kind of in, I'm not going to say crisis, but it's definitely a time where we need to work out what we can do. And if you're going to try and attack that, you need to be able to experiment quickly and at low cost, because you need to try things out, see if they help, and if they don't, move on to something else. But it's interesting because I saw Linda Rising talking about experimentation at an Agile conference last year. And she said, actually, most people's idea of when people talk about experimentation, they're not really experimenting because they don't have a hypothesis, and they'll never turn it off if it fails. So experiment for most organisations just means try. And there's a reason for that. It's because if you spend quite a lot of money building something new, particularly if it was your idea as a product person, there's very little that's going to convince you to turn it off, because you sunk all this cost into it. The only way you can get a really experimentation-focused company is if experiments are really cheap and really easy to do. So there are two aspects to that. The first thing is, what about if you want to build a new product, and what if you want to add a new feature to the product? So I'm going to talk about how quickly you can spin up a minimum viable product. And the example I'm going to use is actually Hack Days. So the FT's been running a Hack Day for at least 5 years. So in a hack day, you form teams. We usually have about a day and a half of coding, and then you present. So you want to have something you can show at the end of it, because who wants to go, yeah, we had this idea, we've got nothing. So it's getting just enough to hang together to prove something. So it is totally minimum viable product. When I first started at the FT, on a hack day, at the end of it, someone would be running something on a developer's laptop, or it would be a script sat on top of a website. So it wasn't live, and it probably wasn't real. Nowadays, in a day and a half, it will be running on AWS or on Heroku. It will probably have a DNS entry in front of it, so it will be michaelhackdayproject.ft.com. Or it might even be just hidden behind a feature flag on our actual website. Although do not tell the product owners that that gets done, because they would be absolutely horrified. But that's the change. The change now is we can totally, in a day and a half, get something properly done. In terms of features, we have A/B testing built into ft.com, and we do hundreds of tests a year. We do it behind feature flags. We put paths in the code. We divide our users into cohorts. We might have tests that are only at some subset of our users. So, for example, we may only care about people who subscribe, or we may be looking at people who haven't yet subscribed. And we put them into different cohorts, and we could show them different things. And the reason we can do hundreds of these A/B tests every year, and we genuinely do turn things off if they don't meet the requirement for what we expected the impact to be. The reason we can do that is because we can release code so quickly, and we can release code so often. And the reason we can do, and we release multiple times a day. I mean, we don't actually track all our releases, but I'd say 20 to 30 releases a day across the FT is pretty normal. And it's because of the architectural decisions that we've made. So we're releasing code about 250 times as often now as we were when I first joined the FT. But it doesn't come without cost, because we've adopted a microservice architecture. And microservices, like, they're actually really nice in themselves. I can understand a microservice very easily, but they're talking over HTTP, they're talking to queues, they're complicated. They're this kind of path and mess of things all talking to each other. And microservices are an efficient way of transforming business problems into distributed transaction problems. This is quite an old tweak, but it's as true now as it was 3 years ago, whenever I found it. Basically, you used to be in one application where your calls were made in process. So you could do things in a transaction. So if things went wrong, you could roll the whole thing back and start again. You can't do that nowadays. You have to cope with the idea that things might be consistent eventually, but there'll be a time in the middle when they're not. Or even worse, they might partially fail, or, you know, if you're optimistic, partially succeed. But you have to be able to deal with that, and deal with that inconsistency. So really what I'm saying is distributed systems fail in new and interesting ways. And it has an impact on how we build and operate them, in terms of how we ensure quality. And I think that actually you have to expect to see problems in production that you didn't see on the way to production. We've always seen problems in production that we didn't see on the way to production, and I just like to say that for customers, they have got no ability to distinguish between I got a bad service because someone released code that was broken versus I got a bad service because something completely different happened. So, you know, actually we should be focused on how can we work out something's wrong and fix it, whether it was caused by our code or by something completely different. And I'm going to give you a couple of examples of something that is completely different. We had reports from customers in Hong Kong, India and Singapore about receiving a sorry page on ft.com. So we started looking into it. Basically, we talked to Fastly, who are our CDN provider, so content delivery network. We cache things locally so that people basically get a good performance at ft.com wherever they are. And we could see, yeah, look, it's all going really slowly, and actually for multiple days. We did quite a lot of looking into it, couldn't find any linked releases, couldn't find anything that we thought was the cause until we saw this news story. That looks fake, but I don't think it actually is. But basically, sharks decided they liked the taste of internet cables, and so they were chewing through them. The internet bandwidth was just restricted. Now, it would have affected anything you were doing on the internet, but for our customers, they were just going, well, the FT, it's not working. You know, this isn't something we can actually fix. There's not much we can do to mitigate it, but we can identify it quickly. And I'm really just telling you because I think it's quite a cool story. Another example, and this time is related to the complexity of our architecture as this one. So we have a page, well, we have lists on our site that are curated by our editors. These are the stories you should read in this area. So on the homepage, these are the most interesting stories within sections. It's how a lot of people discover the articles they read on FT. If you look at what gets read, it's the things that are listed. So it's really important to be able to update it as news breaks. And we basically found that it wasn't getting updated, which is like mass kind of, oh my god, we need to fix this. So we quickly realised that the underlying API on our platform was the problem. It was pretty flaky. And we could see from our monitoring that things had started taking a bit longer, and lots of the test requests for the monitoring system were starting to fail. So we knew it was our graph database, actually. We could tell that it was something to do with calling Neo4j, but we couldn't see anything that had changed. There were no recent code releases, there was just nothing. So we managed to kind of mitigate something, like I think in the end we basically routed traffic through to an old cluster. I don't even know how we did it because it took us 6 hours, and by the end I was just frazzled. But the next day we started looking into what caused this. So this is 2 days worth of requests. On the right hand side, and you can't see the colours, but some of those represent 504s, 503s. There's no more than 12 in probably a half-hour period. So a very, very small number of queries to our graph database were erroring, but having this knock-on effect everywhere. And it turned out that someone had made a change to the graph. They'd added more data, they'd added in some information. And effectively, it had made some of our queries really inefficient and had an effect everywhere. And because Neo4j is a graph database, there's no schema, that's not a schema change, it's just loading data. I mean, we even knew that someone had done this, we just didn't know it would have this effect. It turns out that if you link all your authors to the Financial Times node in a graph database, and lots of other things, it doesn't like it, because basically you have thousands of relationships going to a single node. But basically, this is something where we only know this now. It took a team of 10 people 2 days to work out what was going on. I don't think we could ever have predicted that that bit of data that we'd loaded would cause that. And I'm not sure, we may have caught it on a lower environment. We did certainly add some load onto lower environments in the hope that we'd catch this sort of thing in the future. But I guess what I'm getting at is these examples show us that we need to change possibly the way we approach quality. Because actually, if you're focused on having a good experience for your customer, a lot of things that happen in production you would have found very hard to catch on the way. So maybe it's better to catch it when it happens. So I think it's a team sport, and I think that basically it's around QA, dev, and ops all working together on it, obviously. So I think we need to be focused on production, but I also think we need to test on production. And there's 2 reasons for that. The first thing is if you're doing cloud native stuff, if you're really using what the cloud providers give you, and as Marcus said in his talk just now, you actually can't test this locally. There aren't equivalents. It's a queue that Amazon provide, and there isn't something you can run locally that's the same. Our FT.com, the website, doesn't have a staging environment. They have the developer's laptop and production. So those are the only places you can test. And also, production is the only place where you have the full system complexity, the full data, and the actual user behavior. So why not focus your testing there? So I'm going to cover 3 things. I'm going to talk a bit about what cloud native is, or at least what I think it is. Then I want to talk about the testing in production that I think proved very valuable for us. And finally, a little bit about observability, the things that you need so that you can identify problems and fix them fast. So cloud native. So what is cloud native? And it just sounds like one of those things where someone came up with a cool name and just started marketing it. And it's definitely about the cloud. Right? So it's taking your stuff and running it on the cloud. Amazon's AWS, or Microsoft, or Google. But there are 2 ways to migrate to the cloud. You can take the stuff you already had and just shift it and put it on a virtual machine that you buy, that you rent effectively from AWS. So, you've still got a database, an application server, and a web server. You're still doing a lot of management of that stuff. And that's valuable because, you can shut down your data center. You don't have to have people managing that, and you only pay for what you need. But it's not all you can get from moving to the cloud. There are other things you can do that mean you get a much higher advantage of being on the cloud. So cloud native is about building things that benefit from the things the cloud provider can give you, and not just running on the cloud. So what does it mean? Well, the first thing, which is just true for both of the approaches to the cloud, is infrastructure as a service. which is flexible provisioning on demand that you only pay for what you need right now. And typically when you start using the cloud, that's things like buying virtual machines, buying load balancers. But it's not kind of enough, really. The next thing is automation. You don't want to be going into a console and clicking a button when you want a machine. You want to be doing it in an automated way. So, infrastructure code. So you should be scripting how you spin up a server, and one of the reasons you want to do that is because you want all your servers to be the same. And like the famous quote, I think it's from Adrian Cockcroft, is your servers are cattle now, not pets. I don't know if anyone's heard this, but basically, they used to be pets, you gave them names, and if they got sick, you nursed them back to health. Now they're cattle, and you don't do either of those things for cattle. They're indistinguishable. Continuous delivery. It's about frequently delivering value to your customers, and there are three key things to it. The first is the pipeline. So you have an automated pipeline that is reliable, fast, everything goes through it. The second thing is you put things into that pipeline that you care about, so testing. You might put security checks in. It can be manual testing. You can have a bit that says, hey, pause here for testing, then someone says it's fine to go. But the final thing is things are going through it regularly. So you don't go off and code on a feature branch for ages and then have to do merging. You're committing to master regularly. So continuous delivery is kind of important to this. It lets you release changes quickly and regularly, and you can do that with a monolith. But actually, if you also move to microservices, where the individual components are small, they're decoupled, you have less risk with each change that you do, because it's basically much more controlled. There's a smaller blast radius if it goes wrong. And microservices really should have one thing that they know about. So for example, you can have a microservice that understands how to validate the fields of an article and store it in a store. The other thing about microservices is they really should own their own data. And that means that you can store the data in the right data store for what your need is. So in our platform we have Elasticsearch, MongoDB, S3, and Neo4j. So document store, graph store, search, lots of different ways of storing data. Once you have a lot of small services, eventually you don't want to run them all on their own virtual machine. And the obvious thing to do then is to start putting them inside a container. And container just packages everything up. The code and all the dependencies of the stuff it needs and makes it easy to move around. You can run a container for a virtual machine. Sooner or later though, you want to pack loads of containers together, and then you probably want to think about getting an orchestrator. So orchestrators will do things like handle routing, they'll handle stopping and starting. You can say to an orchestrator, I always want to have 2 instances of this application, and I want them to run on different hardware so that there's always going to be one, no matter what happens in the data center. And it will do it for you. The final thing that marks out cloud native is a heavy use of software as a service. And this is basically doing things like using the queues that AWS provides you, buying databases rather than installing and running them yourself. And this is great because you don't want to spend your time on this. Give money to someone else who does this at scale, and you focus on your business problem, and then this is basically handled for you. But this has an impact on testing, because it makes it much harder to test something if it only really exists on AWS. If you want to read more about Cloud Native, there's an excellent ebook. Financial Times is one of the case studies in it, but it basically covers all of these things. It's pretty good. I've uploaded these slides on Speaker Deck, and I will share them. I'll tweet them out afterwards. But it all sounds complicated, I'm sure. It's a lot of new things. It's a multi-year migration, actually, to change to use all of these new things. Even we added in Kubernetes, it took us a year. A small team, but it's a year. And it means making fairly radical changes in how you work. So why would you do it? But it's literally the thing I said at the beginning. Cloud native technologies enable software developers to build great products faster. This is the CNCF of the Cloud Native Computing Foundation, so they would say that. But actually there is some evidence for it as well. It lets you do small releases quickly and frequently. You do a lot more of them. You probably can do them without affecting your customers. You should be able to, which means you do them all the time, and you tend to do them actually in hours rather than out of hours. This is a big change for quality, because if anything goes wrong, all the people who can help you are there. Just as an indication, this is In 2017, we did about 2,500 releases on the content platform. So I went and created an equivalent scale graph for what we had done with our previous platform. There are actual things on there. That's 12. That's about once a month. You can't experiment when you do 12 releases a year. There's no chance to try something out at all. But you can when you have 2,500. And some changes are much easier to understand. And a decoupled architecture means they likely are very self-contained, and they tend to go right more often than big changes. And I'm not just saying that because basically there is this book, which I highly recommend. It's by Nicole Forsgren, Jez Humble, and Gene Kim. You should read it. It is about the evidence behind how releasing frequently improves your organisation. Improves your organisation in so many ways, not least in terms of income. It's actually profitable to be like this. It also has happier people working there. It's really good. One of the things that they found is that the more often you release, the lower your failure rate for your releases. So this is not something people tend to think. They think, oh my god, if we release all the time, we're just going to be constantly like getting problems. But no, it's not the case, because each of these changes is really small. And I worked it out. 1 or 2 of those 12 releases a year would fail. It's about 15%. Comfortably less than 25 releases failed in 2017. That's less than 1%. That's a huge change in terms of not having to work out what went wrong and fix it up. You don't have to choose between speed and stability. You choose speed in order to get stability. But optimizing for speed has an impact on testing. So why does the focus for testing change? Well, the kind of testing you do when you've got you release once a month doesn't work when you're going to release 10 times a day. So when you have I'm working for 3 weeks developing, and I have a 1-week testing cycle where I'm going to do a lot of regression testing. It's needed because there's a lot of independent changes all shoved into that one release. That's great. You start doing releases more quickly, you can't keep the same length of time for doing testing. Testing quickly becomes a bottleneck. You need to recruit more testers. You're spending more time testing than you are developing. So you need to find out a way to speed up the testing. And what normally happens is people introduce automated testing or introduce more automated testing. But you're still going to want to do exploratory testing, because automated testing I think is great for regression testing, but you want to be doing testing the new stuff and finding the bits where someone didn't do the right automated testing for this new feature. But you have to find a way to start realizing where your scope of testing should be. It's not possible to keep testing everything every time. You're not going to find stuff across all of it, and you're just spending a lot of effort for not so much reward. And you need to think about the risk. Small change going to production, if you can spot very quickly whether it worked or not after it goes to production, is that going to be okay? There's a great blog post and also a conference talk from Sally Goble, who used to head up QA at The Guardian. So she's talking about exactly the same industry as me. And she basically said, well, maybe it's okay to go fast and occasionally have something looking a bit wrong on the website and to pick it up and fix it. So they basically decided they couldn't keep doing pre-release testing the way they had done it before they'd been moving this fast. And effectively their QAs moved to be almost like first point of contact with a lot of their customers. So they're almost like, when things are going wrong, we get told about them. They also continue to do testing, but the focus shifted. We have an internal conference at FT, and we had a session on quality a few years ago, and this was a quote from one of our developers. We're not a nuclear power station or hospital. If we get it wrong, no one dies. So, how careful do we need to be about releasing stuff? Now, I know Angie was talking this morning about not wanting to wait till something's in production to test it, and I'm totally aware that you need to work out the risk. So we wouldn't do this with stuff that had personal data, because we don't want to get a fine for GDPR or data breaches. And we would be very careful about security-related stuff. But for things that are moving things around on the website, get it out there and then work out whether it went wrong. And we've changed the culture of our stakeholders at the FT so that they value a quick turnaround of their ideas enough that they'll accept that sometimes things don't quite work out and they tell us we can fix it. So I think we have changed our balance of pre-release to post-release testing, and I think it's a good thing. I still think obviously we should be doing pre-release testing. But what do I think's the most important stuff there? Well, we still need to be writing automated tests for the service. They're quick to run. You get a lot of value from properly testing the boundaries, and I actually think the best return for a microservice is at the boundary. So making a request in and looking at the response. If you've got a system that looks a bit like this is a great blog post, which is why I've kind of snuck it in here, but actually I'm mostly talking about the diagram. If you're testing A's interaction with B, you don't want to have to run C and D and have a Redis database running. So actually what you want to do is mock out B. And if you're doing that, using the unit test framework seems to me to be a sensible thing to do. And actually, I like to try and get developers to do their testing at the boundary of the service. And not repeat it as a second set of automated tests. I'd rather get the QAs to work with the developers to make sure every scenario is covered in the original unit test. I think you need to be careful not to end up regression testing the whole system. Because your microservice shouldn't have an impact on a service that's somewhere over the far end of it. You might be thinking, well, of course we don't do manual regression testing, we do automated acceptance tests, and they're so quick to run, we'll run them every time, and it doesn't matter that some of them are going to be related to this change. But acceptance tests running locally pushes developers towards the full stack on their laptop. So first of all, that isn't possible for some of these new architectures, but secondly, it's a really bad idea. Because what it means is you have two ways of running your system. The real way, and the way that makes it work on the developer's laptop. And if, like us, you have people using Linux, Mac, and Windows, you actually have 4 different cloud providers, and 3 of them are really sucky. They don't work. So, basically what you end up with if you do this, and I saw Martin talking about contract testing earlier, and he said this, but effectively, you end up with a distributed monolith. Basically, you're treating your system as though it's still a monolith, but now it's one that's got all these calls out in the middle where the communication can't be relied on. And I think, I'm speaking from experience here. We started out, we wrote some acceptance tests for content publishing. So we basically said, we want to know whether an article was published correctly. And actually, developers did have to run everything locally on their laptop to be able to run these acceptance tests. And pretty quickly, they just didn't do that, and they just waited for them to run in the build pipeline. And then pretty quickly after that, they weren't even paying attention to whether they passed in the build pipeline. And there's kind of 2 ways to deal with that, but it wasn't something that they found rewarding. It's a lot of effort to keep it working, because test fixtures can be very brittle. If you're trying to set up data in a microservices world, let's say for validating an article, you need to have people information in the people store, and you need to have topic information in the topic store, and there's all these different places where you need to set up data. And it's actually really hard to maintain that. So what ended up happening was, rather than the first flow, where you develop, you run the acceptance tests, you get the second flow, develop, fix the acceptance tests, run the acceptance tests. But in fact, mostly we got the third one, which is develop, spend more time fixing the acceptance tests than you did doing the developing, and then run them. So this is a real example. 30-minute code change, 2 weeks to get the acceptance tests to pass. I mean, they had been badly put together. Every single fixture was its own file, and there was no way to find the ones that had the field that had changed, and it was just really difficult, but it's very easy to get into that position. It's not a worthwhile return on investment in any way. And almost all the time, the code was fine, but the tests were broken. So people stopped valuing them even more. And because they weren't in the critical path for deployment, they didn't stop deploys. And we had a choice: move it into the critical path so that people have to properly deal with them, or learn from the pain, which was, you know what, they're brittle, they don't catch real issues, and we all hate them. So we need to kill them and look at other solutions. And actually those solutions weren't just tests that we ran pre-release. They were things that we ran in production and in other environments. And they were things that ran all the time. And they could also catch problems caused by our cloud provider, caused by third parties. So they gave us much more than those acceptance tests gave us. So the first thing we did was we introduced synthetic monitoring. And when I talk about synthetic monitoring. I mean, it's synthetic because it's not real. It's monitoring because it's running all the time. Basically what we did is we took an old article, a really old article, and we just republished it once a minute. And this replaced our acceptance test completely. Now, it didn't cover the breadth, because it was only one article, but it captures the vast majority of problems that we're having with publishing. And the way it works is we have a synthetic monitoring service, and it basically, and the system below is a simplified version of our flow. It sends the same kind of publish event in that our content management systems do. And then it just keeps checking the read API. And it basically keeps checking, and if it hasn't seen that the new version has been published, and we tag each of them with a unique identifier that we store as a publish ref, if it hasn't done it within 2 minutes, it decides that that was a failure. Because, you know, in these kind of distributed systems, you have to set yourself a time limit and say, this is what it means to fail to succeed. And then we actually just monitored that the same way we manage any other service, which is we basically say, are you healthy? And it returns, I am unhealthy if publishing is not working. This is a new pattern for us at the FT, and it took a while to persuade people not to bounce the synthetic monitoring service when publishing wasn't well, because oh look, it's red. Well, yeah, it's telling us that publishing is not working. The best thing about this is there are no data fixtures required whatsoever. The system is a black box. You poke something in at one end, and you read something out of the other, and you rely on whatever data is really there. So production, it's just running for real. We're lucky we have no personal information, and not a huge scale of data, so we just copy all of the data into testing and do exactly the same tests in our staging environment as well. And you know, it helps us know things are broken before our users do. The thing about publishing articles is it's not something that happens on a regular basis. There are peaks in the day where all the journalists are publishing stuff, and there are times of the day and of the year when not much happens. If you set up an alert that says, I want to know where no publishing has happened for a while, because that's probably bad news, the first time it fires will be Christmas Day. And no one likes to be phoned up on Christmas Day. No journalists are publishing stuff. There's a reason. Second thing, second bit of advice, I guess, is know when things are working in production. Synthetic monitoring is great, but it doesn't help us with a lot of other common problems. So our editorial team is very inventive, and that's because they have to deal with a very monolithic content management system that's very difficult to use. So if they can find a way to get what they want appearing on our website, they will do. And that means it's good to keep an eye on what they're actually doing in production. So what we do is we basically look at every publisher and we work out whether it's successful. But what does it mean for a publish to be successful? So for us, we have a whole bunch of servers in the EU, a whole bunch of servers in the US. And within there, we have many different APIs backed by many different data stores. So for publishing to be successful, it needs to be in both places. It needs to be in all the stores. And we need to have that within a time period. So effectively what we do, another service that validates for successive publishing for every publish event. So it's notified, so it listens to the notifications that something got published. And then it effectively just checks all of the places where we need to get this content. And again, if it doesn't happen within 2 minutes, reports it's unhealthy. So that tells us what's really happening in production. And actually, we also take all of those publishers and stick them through our staging pipeline. So if we're changing code, we're getting real publishers through so we can spot whether there's something we're about to release that's causing problems. Another good thing to do is to define what you expect. So one of the things I like about that publishing monitoring service is it defines what we mean by successful publishing. There are other ways to do it. And contract testing, I saw Martin's talk earlier, involves a client registering a contract saying, this is what I expect from you. So the idea is that the provider can test that contract against all of its changes and find out early whether it's broken something. And it's good, because basically the client will just say which are the fields that matter the most to them. And I'm cheating a bit to talk about it because we don't do it. I would really like to do it, but I really want to do it on the boundaries between teams within the FT, because that's where things go wrong for us. It's where you basically assume that this thing has been done, but it hasn't because the other team didn't quite do it. They said they'd finish it by Friday, but actually they got delayed, they forgot to tell you, you made your change. We've had lots of production issues like that in the last couple of years. I know people that do it within a system as well. I think that could be one of those things that takes quite a lot of maintenance. If you're basically within a set of microservices trying to define the contract and maintain it, I'm not sure whether the value is enough. Simple documentation can be enough. You don't need to do contract testing. And obviously documentation has a tendency to go out of date. But there are some bits within your system that don't change that much but cause a lot of confusion. One thing we have is that we tag metadata on all of the stuff that gets displayed on our website. And editorial have in their mind these rules for what gets shown where. And one of our developers created these decision trees to document what those rules were. So it's things like, well, is this an opinion piece? Okay, so in that case, we don't show this tag. Is it genre? Okay, then we do this. It was really helpful. And people constantly post these images into Slack to say, no, this is working fine, whenever someone says, oh, I'm sure this should show something different. The other thing that was interesting about that, Matt sent me these yesterday, and this is basically the initial pass from editorial to try and work out those decision trees. And you see, things loop around a lot. They didn't really have a very clear view of exactly how it should work themselves, so even documenting it made everybody understand it better. Drove out the understanding. There's no reason releasing code has to be all or nothing. There are several approaches that let you reduce risk, and then actually let you do testing in production with real data, but with very little impact on other users. So feature flags, release the code, turn on the feature later. That's basically a pretty good idea, and we do that on ft.com. But we can turn the flags on for everybody. We can also just turn them on for individual people. So you can go in and say, oh, I'd like to have this flag turned on. And that means that you can totally test something ahead of releasing it to everybody else. Canary releases. Another way to reduce the risk is to just not show things to as many users in the first place. So on ft.com, we do this for some key parts of our stack. Ones where if it went wrong, we would basically take the site down. And the way this works is the new code goes onto a new instance of the application, and we direct a small amount of our traffic to it. And we can monitor. So we can see, okay, we fired up some new code onto a Canary. We can tell that the response times were pretty comparable. We'd have looked at error rates as well. And then we say, yeah, that's fine. Kill the Canary and start putting it out for real. This is a really good blog post about testing in production, also from Cindy, and it is well worth reading. Testing in production is about finding problems as quickly as possible. It's not the whole story. Once you find a problem, how do you increase the chances you can fix it? Well, the first thing to do is mitigate, and I think as QAs you have something you can do here that's really good, which is basically when a developer starts getting heads down trying to work out what's gone wrong, ask them what they could do to just make it better first. So could they roll code back? Could they fail something over? And I've had so many discussions with people where they're like, it can't be the release. Now I know the release went out at the same time, but it can't be the release. And then you roll back the release and it's fine. So roll back the release, even if you think there is absolutely 0% chance that it's the release, and you can work out why later. But once you've done some kind of mitigation, you need to be able to work out what's going on. So you need to build things with observability in mind. So as a QA, you should be expecting this from your development team. If they're not doing it, can you ask, basically say, hey, actually this would make everything better. It will make your life better. It will make my life better. Log aggregation. So if you're building a complicated architecture with microservices, the logs are everywhere. A request can go through multiple different services. You don't want to be jumping on all of these machines to see it. So you need all your logs to be in one place. But that's not enough, because there are lots of logs. You need to be able to identify the event you care about, and the way we do that is through transaction IDs. So every microservice we write needs to check for a header on a request that has a value that is a unique identifier that says it's this event. If it doesn't find a value, it should create one, and it basically needs to put it out on every log, pass it on in every message and every call that it makes to another microservice. And this means that you can go into your log aggregator and say, I would like to see all the logs for transaction ABC, and you will see them all. And this is so useful that it is just done. You almost never find a case where there's a service that hasn't done this, because it would be so annoying for anyone to be able to support that service. The other thing that's nice about that is you can use prefixes. So we use a synthetic prefix to deliberately exclude some logs from calculations. So our synthetic publishing can sometimes be 90% of our publishers, but we don't include it in our stats of how long it takes to publish. We don't want to tell people this is a new article because it isn't, it's a really old article. We can use that to filter things out. When people are woken up at 3 in the morning and asked to solve a complicated problem, they are cognitively impaired. It's the equivalent of being drunk, because you were deeply asleep and now you're expected, under high stress, to fix the website. So you want to make it easy. So you need to practice things. You practice the things that might go wrong, because you don't want to discover when something has got wrong that the documentation has a key step missing, or that the person trying to fix it has not got permission to get onto this box. Until you practice it, you don't actually know any of those things. And there's a great quote from Jez Humble and Dave Farley in the Delivery book: if it hurts, do it more frequently. Bring the pain forward. If you practice stuff, people might say, oh, I don't want to do this because it's really like error prone and we might make a mistake. And it's like, well, that's exactly the point. It's still something that could go wrong at 2 in the morning. So practice it now and make it better. So we get this a lot about things like, oh yeah, should we actually shut down one of our data centers? And people are like, no, that's really, really risky. It's like, well, it's going to happen at some point. So we could practice it now, and maybe when it does happen, it'll be less bad. The basic things are things like failovers and database restores. I am astonished at how many database backups no one has ever tried to restore. Until you've restored a database backup, you don't have a backup. You have a file. If you're lucky, actually, you may have a file. And I do know cases where someone has had to do a restore because something has gone wrong. I mean, there are some famous ones where they go, oh yeah, it turns out backup hasn't been running, and we don't know how to restore it. That's not a thing that you want to have to do or to have on your CV, to be honest. You just want it to work. Chaos engineering is cool. I mean, it's cool to think of having a job title of chaos engineer, but it's actually a terrifying word to use with the business. They're like, what, you want to unleash chaos? But the point is, it's not about that. And I know that like Netflix have renamed their chaos engineering team to be their resilience engineering team, which is less cool, but probably much less scary. To do chaos engineering, what you have to do first is know what normal looks like. And I heard someone at a talk say they ran a chaos engineering experiment with a team where they actually didn't change anything because they wanted to know if that team understood what normal looked like. And the team spent hours going, oh, well, this graph looks a bit funny, and they were looking for something, but they had no idea what normal was. And then you think about what you can change. A server going down, a spike in traffic, something going wrong with the network. Something where you expect your system to be resilient, because don't break production, it will make you unpopular. And then you think about what alerts are going to go off. What do you expect to see happen? What's going to happen to my graphs? What monitoring will work? So basically have a hypothesis and then do it and see if you were right. And if you're anything like us, the first couple of times you'll do it, you will basically take down an entire region and notice that nothing goes red, no one could have told, and you're like, oh, something's wrong. First time we attempted to fail over between our 2 data centers, we unplugged the network connection into one of the data centers, went to do the failover and discovered that the failover only worked if both data centers were up. That was a very quick Saturday weekend of working because we had to basically stop, do it all over again. So I think you need to use the skills that you already have as QAs, because I think, honestly, the skills that a QA has is totally valuable to me when things go wrong. Because first of all, good QAs understand the features of system at least as well as the product owner and much better than most developers. Because you do lots of things that are end to end. If I want to know how something works, it's the QA that I go to. I think chaos engineering uses a lot of the same skills as exploratory testing. What happens if I poke this? How about if I was to unplug that? I feel like a natural place for QAs to be working is, let's do this different, like it's basically the operations world exploratory testing. We expect our developers, if you're doing DevOps, we expect your developers to get a lot more involved in operational stuff. We found it took longer for QAs to get involved there. I kind of don't want anything that we do as a team not to have someone checking for quality, and that includes scripts that we're writing. You know, sit with a developer and ask them what they're doing, and you'll probably find so many ways to improve things and to fix it up. Validate and test this stuff too. So, just to wrap up, what worked well before Cloud Native I don't think works so well now, and I don't think it's just a question of shifting left. I think you need to focus on the maximum value for your customers with the minimum time when things are broken and unavailable, but there's some balance there. You know, because it's the old thing, like the reason DevOps came about is because developers want to change things all the time and ops want to never release code. It's the same with this. It's like, how fast do you want to go and how much risk do you want to take? I think you understand where the QA mindset is really valuable and move there. And QAs have done this like so many times. You know, I go back to the days when testers were running through hundreds of steps manually that were in an Excel file. You know, that's not testing anymore. So there's lots of, you're very adaptable and you have skills that are incredibly useful. But my final top tips. So, use synthetic monitoring. Anything that lets you know what's going on. Clever monitoring. Something that understands what you're trying to achieve. Make sure the logs are aggregated. With the tracing of the events, and know how to make those queries so that you can basically find the information that you need. We use Splunk. If you really understand Splunk query language, you're like a hero in your organisation. You'll spend your life helping people out. Practice things, because the more you practice stuff, the better it goes. I'm now bizarrely in charge of business continuity at FT, and we practice by basically telling everyone in tech and product to work from home. We're like, this is a practice of what we would do if we couldn't get into an office. It really helps you learn stuff. Chaos engineering is exploratory testing. That's basically what it is. So, thank you.